what we're going to do here today is talk a little more specifically about regular polygons. We mentioned how to find the measures of their angles, but today we're going to talk about how to calculate their areas. And in order to do that, and before we do that, I want to go over what some of the terminology is going to be and how these regular polygons are going to be broken up. Remember, once again, a regular polygon means it's equal sides and equal angles. Okay, and so the first thing, or the couple things to look at, is what the different variables are going to represent. Okay, so when we use S, these are S's, not 5's here, but S is the length of each side in your regular polygon. N is going to represent the number of sides. Okay, and then P would be representing the perimeter. And do keep in mind that the perimeter of a regular polygon is going to be the length of each side times the number of sides. So S times N is the calculation for perimeter. The last thing that I want to do, just talking in general about the regular polygon, is every regular polygon is created or can be referenced using congruent triangles originating from the center of that polygon that will always be isosceles, right? Because these represent the regular polygon can always be inscribed in a circle. And so the sides of this reference triangle are always going to be radii of that circle that encloses the polygon. Okay, so this is always going to be an isosceles triangle, okay, which means you have a couple pieces of information about that isosceles triangle. First is, whatever the number of sides is, there's that many reference triangles. Okay, so I will refer to these as reference triangles. The reference triangles are isosceles. And the number of reference triangles is also going to equal the number of sides, n. Which means if I want to find this vertex angle, I'll call it A right here. Well, I'm not going to call it A because that's for something else. Let's call it theta here. This angle right here that is the vertex angle of your reference triangle can be found by taking 360 degrees, right, the full rotation of the circle, right, and dividing it by the number of sides, n. And that tells you what that reference angle has to be. So here if we have 1, 2, 3, 4, 5 sides, so in this particular example, n is equal to 5, which means theta is going to be 360 over 5. And if you identify what that measure is, 5 goes into 36 7 times with 1 remaining, 5 goes into 10 2 times. Right? And so this angle right here is 72 degrees. Knowing that reference angle and being able to calculate it is going to be a part of what you use in the calculations for the area of any random regular polygon. All right, so what I want you to do here is see if you can answer this first question. Okay, so this is the central angle of that reference triangle. Okay, and so what you will likely see is anytime I'm working with a regular n-sided polygon, a regular n-gon, okay, I will draw one reference triangle, and then I'll kind of extend the lines off to the side, and that just indicates some polygon, and I'll label the number of sides somewhere near the sketch. Okay, so if I sketch something like this, it means that you have a regular polygon with 13 sides. Okay, so that's going to tell you that what is this angle measure here of our reference triangle? 360 divided by 13. Okay, and so that's all you would have to do to find that reference angle. Now, the last thing to think about before we move on from this is we're going to be using these reference triangles to find the area. Okay, so in order to find the area, we need to know the base of this reference triangle, which is S, and we need to know its height. The height right here is going to be labeled A. The A value it's called the apothem, but it's really just the altitude. Again, the term altitude makes more sense to students. So it's the altitude of that reference triangle. Okay, so this perpendicular right here is going to be the altitude of that reference triangle. And because it's an isosceles triangle to begin with, when you draw the perpendicular to the base of an isosceles triangle, it bisects that base. So each of these right triangles that are formed right here are going to be half of the length, the side length S. All right, so all of that comes into play here as we move forward. Now, for this one right here, if you were calculating this, so you'd get 360 divided by 13, 27.7 approximately would be the total angle measure of that reference angle. Now again, that's this whole reference angle of the isosceles triangle. And once again, this is going to be isosceles. All right, so this is all of the background that we are going to look at. The remaining problems that we're going over are going to be how to calculate the area. And it all depends on what information is provided, because there's two formulas that we'll use for calculating the area of a regular polygon. Okay? They're both based on the fact that if you took one reference triangle, so if we took this reference triangle with a length of S, this altitude or apothem measure A, and then n being the number of sides, what you can do is you can find the area of a regular polygon is equal to, if I find the area of just one triangle, what would be the area formula for this shape, this highlighted triangle? 1/2 a base of what? Well, so it's an S, but yes. So that length S. And then what's the height of that triangle? A. So right there, that's the area of one reference triangle. And so you don't necessarily have to memorize a formula for regular polygons, even though you're going to see one. But all it is it's the area of this one reference triangle. And then how many of these reference triangles are there? There's one for each side of this figure, so we're going to multiply that by n. And so your formulas are 1/2 SAN. Okay. And because if we look back here on the previous slide, right here, P is equivalent to S times N. What we can do is if we take S times N, we can replace that with the perimeter. You could also call this 1/2 A times replace S and N with P. So these are your two area formulas for a regular polygon. So if you're just given the information, like in these two problems, plug in the correct information, use the correct formula. And so I want you to see if you can answer these first two questions. What's the area of these regular polygons given the information provided? Okay, so it looks like most of you are in the habit of what I'm hoping for anyway, which is entering your answer as a calculation. It makes it really easy to solve these kind of problems, right? If they give you the n value is 6 with a side length of 12 and the apothem or altitude of 10.39, then that's just the very first calculation, 1/2 S, which is 12, times A, which is 10.39, times N, which is 6. And so that would be your answer. If you entered that, you can get a calculated value. But in my opinion, it's easiest just to enter the calculation. But you get 374.04 as your calculated answer. Okay, in the second problem here, you're asked to find the area. You're given a perimeter. So P is equal to 156.65. You're given the apothem. So A is equal to 24.44, and that is enough information to use the second formula. So once again, it's 1/2 our A value, 24.44, times our P value, 156.65. And notice here, it didn't even tell you how many sides you had, right? It's not necessary for this. And if we calculated our answer, we get 1/2 times 24.44 times our perimeter, 156.65, and we get our answer to be 1914.263 as our solution. All right, any questions on those? My expectation is that it's just a matter of either knowing the formula, being able to derive it, that those are your straightforward questions. Okay, the remaining ones that we're going to go through today are the ones that are a little more challenging. All right. So if we're taking and solving the area of a regular polygon, and remember it's 1/2 SAN or 1/2 AP. Okay, and so for this one, I want you to try this on your own. Okay, see if you can find this measure based on the given information. So this is sort of the next level, and that is now it doesn't just give you the S, the A, the N. This one might incorporate the given area and then ask you to find one of those other. So once again, you can still enter your answer as calculations for these types of problems. It's just a matter of setting up your formula correctly. Okay, so here you're given N is 23, capital A is given, and the side length S is given. And so that's telling you, since you're finding what A is, you are using this top equation. And so if you set it up as 40,202.82 is equal to 1/2 times S times A, which is our unknown, times N. And now it's just a matter of recalculating. Okay, so a couple options for doing this. One, you could literally divide by each of these factors, including the 1/2 that have the numbers. And that is acceptable. If you enter this as your answer, the 1/2 cancels, 31 cancels, 23 cancels. If you enter this answer right here or as a calculation, it will give you the correct answer. So here if you have 40,202.82 and we divide by, it doesn't matter that you have a fraction in the denominator. You can continue to work with that. Okay, and so here would be my answer of 112.77. So whether you enter the calculation or the calculated value. Now you can also get rid of the 1/2 by multiplying by 2 instead of dividing by 1/2, but it's not necessary. It makes it nice and easy and straightforward to do it this way. All right, so try these remaining 2 questions, same idea. You're given all the information that you need, okay, but now you're not just solving for A, you're solving for one of the variables in the formula itself. A couple different options here when you're solving these types of problems. If a lot of you write out your equations directly in the answer field and then you manipulate them there, which is fine if that's how you do it. You can also figure out which equation you need to use. So here I have my N value, I have my capital A value, and I have my lowercase a value. So that tells me I'm using this top equation, but I'm being asked to solve for S. And so it's also possible that you could take this whole equation here and solve for S first. So if I isolate S, I'm dividing by 1/2 A and N. So divide by 1/2 A and N. And so I can then take that form and substitute in the known values in my answer entry. So my capital A is 1068.05, divide by the 1/2 times my lowercase a, my apothem, 18.26, times my N value, which is 13. And so I could enter that as my calculation. So you can set up the calculation first. And then just type in the pieces exactly where they fit. And that would give you your answer to be, if you round it to 2 decimals, 9.00 approximately, but you can leave the answer as that calculation to get the exact value. And then again, finally, if you're looking here, you have n, the number of sides, capital A, and you have lowercase a, and you're solving for p. Well, p involves this second equation. And so if you plug this in, so there's our a value is equal to 1/2 our a, which is 56.93, times our p value. Notice, did I even need to use this 19? No. The only way you would use that is if you took the perimeter divided by 19 to find what each s value is and then plug that into the first calculation or the first formula. You could do that, but the s times n is just going to turn out to be the 5693, or you'd have to find what the s is separately and then plug that back in times 19 to get your perimeter. So might as well just use the formula that has perimeter in it. So if I divide both sides by these factors, the half cancels, 56.93 cancels. There's my perimeter, 10,275.93, and divide that by the calculated value, 1/2, 56.93. And so if I left it that way, I'd have my solution, or if I did my full calculation, I get 361.00, and that would give me my answer. All right, so slight level of difficulty increase, but still all the information that you need is presented to you, and it's just a matter of you plugging in the right pieces of information. We're only going to go through this special case, and so this is the only other one that you need to know besides being able to plug it right in, and that is you're still using 1/2 SAN, except for one unique thing. When you draw this reference triangle for a regular hexagon, okay, meaning your n is 6, what is that vertex angle? So again, this is an isosceles triangle here. What would that vertex angle be? 360 divided by n, which gives you 60. And if you have a vertex angle of 60 and you know that those two sides are the same, what do each of the other two angles of that reference triangle have to be? Also 60. So what you see right here is that this reference triangle is equilateral. And what that means is when you draw in your altitude, what type of a triangle is created here? Use the properties of a 30, 60, 90 triangle. Okay? And so now, if we know that the side length here is S, this piece right here is going to be 1/2 of S, which means the A value is going to be 1/2 of S times what? You remember the pattern for a 30, 60, 90? We have, we have this piece, x, 2x, x root 3. So that means that we would wind up taking 1/2 of s times root 3. Now you don't need to memorize this as a formula. Okay? I mean, you can. If you plug this in, we would get 1/2 the s value times my a value, which is 1/2 s times root 3, and then my n value, which is 6. So we could kind of simplify what we're working with here, right? I mean, the 2 goes into 6, leaving 3. So you wind up having 3 s squared times root 3 all over 2. Okay? But like I said, you don't need to memorize this as a formula, okay? Because all I'm going to do when I sketch this is I'm going to sketch one reference triangle. Okay? When I sketch this, I know I have 60 degrees here, which makes this 30, 60, 90. And so if the side length is 34, and I want to find my area, 1/2 SAN, I have my side length of 34. And when I draw that, what's this portion of that side going to be? One leg is 1/2 of 34, so that's 17, which means this height right here is going to be 17 times √3. There's my A value. And what's my N value in a hexagon? 6. And so there's my calculation. So once again, if you just entered that as your calculation, you're good. If you do the full calculation here, so 1/2 of 34 times 17 square root 3 times 6, you get your answer. It's 3003.38, and that would be your answer. All right, so for this final question, okay, see if you can answer that. When you draw your reference triangle, because it's a regular hexagon, we have an equilateral triangle, draw in our altitude to create 30, 60, 90. So if the perimeter is 264, and perimeter is the number of sides times the side length, S. If we took 264 divided by 6, we get each side length here is going to equal 44. So this whole thing is 44, which means when we break this down, this leg is 1/2 of 44, meaning this altitude is 22√3, and now we have our information. So our area is 1/2. Our S value, now remember, your S value is this whole length. I guarantee a number of you are going to make the mistake of using 22 as your S value. Does everybody see that S is not 22? S is 44. Make sure you use that full length. 1/2 base times my height, 22√3. So that right there, what I have right here is just the area formula of a triangle. So it's not like you had to try to learn something new. We're just finding the area of that triangle, and then how many of these triangles are going to fit around this polygon? The number of sides, 6. And so that is your calculation. And once again, if you're doing the math on this, 1/2 44 times 22 square root 3 times 6, and we get our answer to be 5,029. 0.86, or sorry, 0.88